I'd like to take a moment to review how the graph of a polar relation is constructed. Understanding how a polar graph is made can help us significantly with the understanding of calculus as it applies to polar curves. Unlike a rectangular relation, which uses the coordinates in the Cartesian coordinate plane, and it relates the horizontal position of the x-coordinate to the vertical position or the y-coordinate of a point, a polar curve defines the distance that a point is from the origin, which is also known as a pole, given an angle from the positive x-axis. I'm going to use this relation right here, r of theta equals 1 minus cosine of theta, should be theta there, to demonstrate how a polar curve can be constructed. What we have here is a point B. This point B is going to be on our polar relation. It's going to be represented by this triangle here. And B is going to move depending on what theta is. And theta is going to be the angle that this green line makes with the x-axis. Now, right now, theta is set at 0 pi, or just 0. But what we're going to do is we're going to move theta so that that green line rotates. Right now, when theta is 0, if we plug 0 in for the cosine of theta right here, cosine of 0 is going to be 1, and 1 minus 1 is 0. So when theta is 0, b is going to be 0. So let's look at what happens when theta increases. I'm going to increase theta to pi over 2, or 0.5 pi. That would be pi over 2. So when I increase theta to pi over 2, cosine of pi over 2 is going to be 0, so 1 minus 0 is going to give us 1. So we'll notice now that our green line here is in the upward direction because it's making a 90 degree or a pi over 2 angle with the positive x-axis. And our point now is at a value of 1 because, well, 1 minus 0 is 1. If I increase theta to a different value, I'm just going to pick a random one here, say 0.81 times pi. Now the distance between the origin and our point is going to be 1.83 along that angle. So as this green line here swings around, theta changes, and as a result, this distance from the origin changes. And what we can do is we can look at what happens as theta goes from 0 all the way around to 2 pi, and we can see how that point is affected. Now, what I'm going to do here is I'm going to trace this point and see what this curve is going to look like as theta changes. So we can see that as theta increases, the point gets further away from the origin for a while, and that pole or that line is swinging around, and then it starts getting closer. And so what we get here is what's called a dimpled limacon, and it's kind of a circle with an indentation in it. When I graph a polar curve, I like to think of this line right here swinging around the origin, and that point just being a distance along that line away from the origin. That helps me understand what the curve is going to be doing and understand that everything is centered around that origin or centered on that origin. Another thing to keep in mind is if we had a graph or a relation where the value of r is ever going to be less than 0, instead of being a distance along this green line here away from the origin, it would be in the negative direction, so along the red side of it here. And so I want to look at one other relation. I'm going to change our relation to 1/2 minus cosine of theta. And when we do that, we'll see that our initial value when theta is 0 is now going to be negative 1/2. So our point is along the red part of our line by a distance of 1/2, so it's on the negative side. So even though our theta is 0, so we're on the positive x-axis, it's going to be on the negative x-axis because our value is negative. And again, we can trace this and see what's going to happen as theta increases, and we're going to get some negative and positive values for theta depending on, for r, depending on what theta is, and we get now a limacon with an inner loop. So we can see now we're at positive values because we're on the green side of our line, and once we get past a point here, it's going to go through the origin, and we've got our inner loop there. So with negative values, we can plot those. It's just going to be along the angle but on the opposite side of our ray.